Hello everyone, I am Pranav Akor, an ENTC student and intern at Emerging under the guidance of Jayalakshmi ma'am. During the tenure of internship, we covered C programming, embedded system and also embedded system using C. We can also say embedded C. We used microcontroller like PIC, but for learning purpose, we use simulations like NPLab ID and PICSIMNet, and we have also done our microwave oven project on MPLab ID and PICSIMLab. So the content we learned in internships for C programming are introduction to C, data types, input and output function, control statement, operator, advanced concept, memory, function. And in embedded system, we cover topics like what is embedded, examples, types, basic peripherals, working of peripherals, architecture, type of memory. Introduction to C programming. C programming was developed by Sir Dennis Ritchie in Bell Lab in 1972. C programming is used for general purpose procedure language embedded system. It is also used for kernel development, OS development. So data types in C programming are the primary data types and derived data types. In primary data types, there are mainly four: integer, float, character, double. In derived data types, we have arrays, pointers, structures, and unions. There are also type modifiers like long int, short int, unsigned int, signed int. The type modifiers are long, short, signed, unsigned. Now, for taking input from user, we uses scanf, fgetS, getS. Now, the difference between scanf and fgetS is scanf we can use it for a single character, and fgetS we can use it for strings, and getIs is also used for string. Now to display the thing, we used printfs or puts. Now control statement and loops. In control statement, there are two types: conditional and jump statement. In conditional, there are if else and switch case. In jump statements, there are break, continue, and go to. While in loops, there are loops like for loop, while loop, and do while loop. Now, if we see for a if else statement, in if the syntax is if left parenthesis, then our condition, right parenthesis, and under that statement we can write our command. And for else we just write else, and under that else we write our next command. So if statement is executed, then else will not be executed and control flow will directly go for the next statement which is after else. But if statement is not executed, then control flow will go for else statement. Now switch case. Switch case works like if else, but they are in a block type format. We need to break the switch case after every conditional statement. Now for jump statement, break means even if there is some infinite loop or anything that goes on continuously, then we can use break statement to come back from that. And now in continue statement, we used it for continuing the program even after there is a error, and go to statement is used for going to the previous commands with the help of control flow. Now we will see operators in C. There are basically five operators like arithmetic, logical, bitwise, assignment, and miscellaneous. Hmm. In arithmetic operator, there is plus, minus, multiplication, and division. In logical, there is and, or, not. And in bitwise, there is and, or, not, XOR, left shift, and right shift. In assignment operator, assign to, addition assignment, subtraction assignment, and multiplication assignment, and division assignment. In size of, we can use it like size of left parenthesis. We can read the data type or a value and right parenthesis. So size of will give us the size required for that specific data type. And the last one is ternary operator. Ternary operator is like conditional operator statement, or we can say we can use it as a conditional statement. Now if we take arithmetic statement operators, plus operator, it has the arity of 2, which means it takes two operands, and the associativity is from left to right. Same with other arithmetic operators. And logical operators, if we take ampersand or and, the arity of and is Logical AND is binary. The associativity is from left to right, which means the execution of that statement will be done from left to right. For example, operand 1, logical and operand 2. If we take bitwise, it's also the same as the logical operator. Mm, mm. In assignment operator, the arity is binary. The associativity is from right to left, which means that whatever the value is present on the right side will be carried or assigned to the operand on the left side. Now switching for advanced concept in C, there are pointers, dynamic memory allocations and structures. Now pointers are basically used to find the address of the variable. Pointers are also the types of a variable. The syntax for pointer is data type, asterisk, variable name and semicolon. Now we have to assign the value or the address in the pointer variable. So the syntax will be pointer variable name, assignment operator, ampersand, and the variable name of which we want to store the address. Now we will go for a dynamic memory allocation. Now dynamic memory allocation is done at the running state of the program, which means even after compilation, if we required a space and we have mentioned it in the code using malloc, which is a function given in C for dynamic memory allocation, then according to the value we passes to malloc, we get the space or size. Now going for introduction to embedded systems. Now what are embedded systems? Embedded systems is a specialized computing system designed to perform dedicated functions within a larger system. Real-time operations often operates and ensuring quick and reliable response. Components it consists of microcontrollers, sensors, and softwares. Application they are used in automobiles, medical service, consumer electronics, industrial automation. They are also used in research. Now the types per category according to their scale. There are small scale, medium scale, sophisticated based on the complexity. Examples of embedded systems are home appliances, medical device, automotive system. Now, types of embedded systems. There are standalone embedded system, real-time embedded system, network embedded system, mobile embedded system, and hybrid embedded systems. Now, in standalone embedded systems, the embedded systems or a controller which we are using does not require another controller for completing the task. Real-time embedded systems. These systems are used for the application where we require a real time or the response from the real time. Examples are pacemakers, which are insulin pumps or automotive system including airbag or flight control system, network embedded system. This system are types of embedded system that rely on wired or wireless networks and communication with web servers or output. These systems are connected to a network to provide output and can communicate with embedded web service through network connections, which basically means we can use them for IoTs. The network embedded system can be used in home automation or automotive segment, like if we want to control our lights or any other electrical appliances from away, we can use network embedded system. Or if we need to use our electrical devices at home but we are at a remote location, so at that time we can use network embedded systems. Now mobile embedded systems. Mobile embedded systems refers to a small portable device such as laptops, phone, tabs, or we can even say a smart watch or digital watch. This system are subset of standalone embedded systems, meaning they can function independently without a host computer, but they are specifically characterized by their probability. Examples are cell phone, wristwatch or digital watch, or laptops, calculator. Now, hybrid embedded systems. Hybrid embedded systems are systems where we use standalone system, real-time system, network system, mobile stable system at a time, or we can combine any of the four to form a hybrid embedded system. Now moving for the components required in embedded system, or we can say peripherals. There are peripherals like switches, display. In display, there are types like LED, LCD. In LCD, there are CLCD, which stands for character liquid crystal display, or GLCD, which is graphical liquid crystal display. There are also buzzers, fan, motors, potentiometers, sensors, and other actuators which we can use as a component or a peripheral components. Now we are looking for a switches. Switches are the devices which we used as a circuit breaker or short circuitors, which means if switch is closed, the circuit will work, and if switch is open, then circuit will not work. Now there are many types of switches like push switch. Now there are also button switches. By using button switches, we can make the keypad which is off by 4 by 3 or 4 by 4. Now we will come to display. In, in display, there are LED which is light emitting diodes. They are used signaling or as a signals. Now going on and LCD. LCD first pin is ground pin. Second is VCC, which means where we are giving voltage supply. Third pin is contrast pin, or we can say output voltage, or VEE. Pin 4 of LCD is RS, which is register select pin, used to toggle between command and data register. Fifth is RW pin, which is used to toggle the display between read and write operation. If R mode is selected, then the data passed to a LCD will be displayed or will be only readable. If W is there, then we can change the data given to a LCD. E pin is enable pin, which acts like a switch. Pin 7 to pin 14 are data pins used to send data to a display pins. Pin 15 and pin 16 are connected to plus 5 volt and ground. Buzzers. Buzzers are used for making alarms or for any alert situation. Fans. Fans are used as a peripheral for a purpose of cooling down any element which carries a heat or which is sensitive to thermal energy. Potentiometers are variable resistors which we used to vary the voltages. Now moving for a embedded system architectures. There are basically two types of architectures. Sir Von Neumann architecture and Sir Howard. In Von Neumann architecture, we are getting control unit and memory holding or data memory as a different variable or in a different block. In Harvard architecture, we are also getting them in a different block like instruction memory and data memory. Whereas in Von Neumann, the program memory and data memory are same. Input and outputs are given differently to a ALU. In Harvard architecture, instruction memory and data memory are different, and IO is given to a control unit directly. In Von Neumann architecture, there are different buses for data and address. In Harvard architecture, there are single bus for data and address. Now, memory types that are used in embedded are RAM, ROM, flash, EEPROM, and cache memory. Now, RAM. RAM is read-only memory or a non-volatile memory used for firmware softwares. So, as RAM is non-volatile memory, so if the power is off or there is no power in a circuit, then the whatever data which is in RAM will be erased. But in ROM, that is random access memory, it is volatile memory which we can use for a temporary data storage. Read-only memory or non-volatile memory used for firm software, which means they can hold a data even after there is a power off, while there is a random access memory RAM which are volatile memory which are used as a temporary data storage, which means if there is no power supply, then the data will be lost. Now flash ROM or flash memory, we can say flash memory is non-volatile. It's rewritable memory for a programmable and data storage. EEPROM is electrically erasable, programmable, read-only memory. Stores small amount of data that need to be retained, and cache memory is used for high-speed memory or for faster processing and data access. Now, for a SoC or system on chip and conclusion. SoC is an IC that consolidates all essential components of a computing system onto a single chip. It includes processor, memory, IO peripherals, GPU, network module, security module. Now, advantages of SoC are compact size, low power, application they are used for a specific purpose only. They are programmable, heterogeneous, and also content multiprocessor. If we take an example of SoC, then it is NVIDIA Jetson. Now we will take a look at a code. Now, this is our code for microwave oven project. First, we have include our xc.h file, which is our header file. After that, we have defined our crystal frequency. After that, we have defined some pragma. After we have given a macros. After macros, we have declared loops functions like LCD, keypad, microwave start, set timer, set temperature, pause, resume, error message, or preheat. Now, here we have written void as a return type for some functions because we are not taking any value from that function, and in argument or in parenthesis after function name, some of them doesn't had any arguments, which means we are not even giving them any argument or variable from our entry point function or main. After that, we have trace D set as output 4 and trace B set as lower 4 bit as output and upper 4 as for input. So we have defined our default cooking time and also delay, which will be this delay, and here we have written while one, which means that the following commands whichever is written in while loop function body will be execute infinitely till we don't stop it. In that we have passed, we have taken, we have passes functions like keypad scan. After that, set time, preheat. After our main body, we have initialized our, we have defined our functions like keypad scan, LCD clear, LCD string, LCD character, and microwave start. Ongoing with error message, preheat, and was resume, set temperature, set time. Now we will take a simulation or look at a simulation. Now in simulation, first we are looking at power on and microwave oven. After that, we are getting four modes which are micro, grill, convection, and start. Now for selecting any of the mode, we have to press key according to the number associated with them. For example, if we want to select micro, we have to press first key or a key which contains the value 1. After that, we have seen a power window. Now we have to set time. And then for set time, we have to use our 4x4 keypad. We are setting time for 10 seconds. After setting time, for entering the time or for assigning that time, we have to press hash. So after that, we have options like start or resume. After starting one time, we can see options like start or resume, pause, and stop. So if we want to pause the operation or the ongoing process, we need to enter 5 using our keypad. If we want to stop our operation or process, we need to press the key 6. For setting temperature, we have to go to a convection mode. After entering the temperature we required, we need to press hash so that the value we entered should be assigned to a temperature in the convection mode. Note that we can't enter value more than the temperature we required. After entering the temperature, we can see a preheating screen and the time remaining. Now in cooking mode and in convection mode, after the time is over, the alarm is used or a buzzer is used to notify it. We can use star to clear the value which we are given or which we have given. Thank you.